My friends, myself Srikanth, studying 8th sem Electrical and Electronics Department, Iron College of Engineering, Bangalore. I am here to discuss about my seminar topic is all solid state A1 batteries with polymer alkaline gel electrolyte under the guidance of Professor Malini KV, head of the Department of Electrical and Electronics Department, Professor Vanilla Faculty, Electrical and Electronics Department. These are the contents. Before going to topic, I want to brief about batteries is a device that stores the chemical energy modes available of electrical form. It is consist of one or more voltaic cells, each of which is composed two of cells connected in series by the conductive electrolyte. Contents. These are the contents. Introduction. The paper-based electrolyte and its application of A1 air batteries, which is targeted by milliwatt application. PVC can either the use of mechanical rechargeable A1 air batteries or be integrated into single-use flexible A1 air batteries. PVC is can moderated by the performance with a peak power density of a 3.8 watt centimeter and an A1 specific capacity of 900 milliampere. Continuation. A1 batteries has been regarded as a promising primary energy technology, which is mainly because of low price, great ambulance, less pollution and high energy density of A1 batteries. Developed by the polymer electrolyte membranes using alkaline and polyacrylic acid for A1 batteries. Abstract. The work demonstrates a novel type of paper-based solid electrolyte and its application in A1 batteries, which is targeted at milliwatt application. Benefits from the solid from electrolyte. A liquid-free operation of the A1 battery is realized, eliminating the potential leakage hardness of, therefore improving the battery packability, and is prepared by integrating gel electrolyte into porous cellular paper, followed by the solution casting process of solidify the gel. The as prepared PVC can either use the mechanical rechargeable A1 batteries or the integrated into single-use flexible A1 batteries. Currently, the PVC can achieve the modern battery performance with a peak power density of 3.8 megawatts. Properties of PVC can be further improved by the comprehensive parametric study of fabrication parameters such as gel concentration, casting temperature, casting timing, porosity, and pore size of paper substrate. Fabrication and testing of A1 batteries with PVC. It consists of three types: the mechanical rechargeable A1 batteries with good shells, the flexible air battery, and battery pack. Battery testing and post-testing working. Figure 1 shows the gel electrolyte was prepared first by dissolved 40 mg sodium polyacrylate powder, 2 ml of 10 ml of sodium hydroxide solution. After sufficient stirring and storing of 24 hours, the final product was transparent gel with high viscosity. Next, 100 microliters. The gel electrolyte was deposited into the filter paper by a pipette to strictly confine the deposition area. The filter paper was sandwiched between two annual polyplates with high pressure. Filter paper was so that the deposit gel electrolyte could not access the acid part of the paper. After the gel electrolyte was fully integrated into paper, it was casting of 60 degrees Celsius of 1 hour to evaporate the excess water inside the gel. In order of achieve the desired solid state, the final product and the schematic diagram of PCB we are showing the figure 1. 2 shows the mechanical rechargeable air battery was mainly composed an even foil anode, a carbon paper cathode, and is PVC switched in between two PMMA shells. We are employed the assemble the three layer together the help of four pairs of bolts and nuts. In addition, window was cutted outlet sheets of cathode sizes air breathing. A foil was connected into the carbon paper by glue as the cathode current collector. As for the anode, A1 foil it is can be used to current collectors. Figure C shows the on the filter of paper first followed by the depositing 20 microliter on the filter paper first followed by the deposit as prepared over ink into a after ink drying the gel electrolyte was deposited into the filter paper from the other side, which was also dried off 60 degrees for 1 hour. Finally, 1 centimeter into 1 centimeter A1 foil was attached to other side of the filter paper, which the help of double conducting CU tap, which also served as anode current collectors in addition to the single cell and 10 cells flexible A1 air battery pack which was also developed in the same way, which was connected in series is to improve the voltage output ability. Mechanical rechargeable A1 batteries with grid cell. Mechanical rechargeable A1 battery was mainly composed an A1 foil anode, a carbon paper cathode, and PVC sandwich in between. Two PMMA cells were employed to assemble the three layer together the help of four pairs of bolts and nuts. AG foils are connected to the carbon paper by glue as a anode current collector. The flexible air battery and battery pack. The develop the flexible A1 air battery, the grid carbon paper can be longer be used the cathode instead of an oxygen reduction reaction. Ink was developed by disappearing 50 grams carbon nanotube and 1.7 mg F1 binder ethanol water solution followed by 30 minutes sonification. The battery structure and shown in figure C. The followed by deposit of overall link by after ink drying the gel electrolyte was deposited into the filter paper from the other side of also dried 60 degree of 1 hour. Finally was attached by either the side of filter paper was helped on a double conductivity CU tap. Battery testing and post-test characteristics. Battery testing was conducted with the help of an electromagnetic workstation to obtain the battery polarization curve and linear sweep photometric technique was used. The battery discharge stability was studied by galvanostic discharge. Corresponding A1 specification capacity was also calculated based on a discharge results. The mechanical rechargeable A1 batteries the use of the PBCE after discharging them was taken out of the further characterization. Physical characteristics of PBCE. Before the electromagnetic testing surface morphology of them as prepared PBCE was investigated from first by SIM as shown in figure A. The Pristine filter paper was composed of multiple intertwined cellulose fiber. After the gel electrolyte deposition, the cellulose fiber and pore between the were coated with the NaOH gel. Overall, some vacant pore could not still absorbing in the PBCE, indicating the space inside paper was not totally filled by the gel electrolyte. The probably because of low pressure environment of sim testing 70%, which promoted the further evaporate water inside the gel. Figure P shows the summarizing the element composition of both pristine filter paper and PBCE since formulation of cellulose of pristine paper is reasonable by adding SPA NaOH gel and Na element was introduced the paper and the figure C compare the icon conductivity between the PBCE and filter paper soaked with NaOH solution. Apparently, PBCE encountered much high resistance than the latter, which mainly because of low ion mobility inside the gel electrolyte. Before the electromagnetic testing, surface molography of the PP was investigated. Of same pristine filter paper was composed of the multi-intertwined cellular fibers. After electrolyte deposit, cellular fiber and pores between them were coating with a SPA NaOH gel. Figure B summarized the elements composition of both pristine filter and FPCE. Figure C pressure of icon conductivity between the PVC and filter paper soaked with NaOH solution. The mechanical rechargeable A1 batteries with PVCE. The air batteries A1 batteries is generally not electrical rechargeable due to the fact of A1 electrode depletion is not thermodynamically feasible in aqueous electrolyte. Nevertheless, it can still mechanically recharge by replacement of existing A1 anode with fresh of manual. This process is quite dangerous of conventional A1 batteries because of potential leakage of corrosive electrolyte. However, by the utilize the present PBCE, the mechanical recharge process would be very safe and convenient. Figure 1 shows the self-performance of mechanical rechargeable A1 batteries with PBCE. Currently, this cell is obtained the 0 volts to 1.5 volts is peak power density of 3.8 megawatts and maximum current density of 5 milliampere. Compared with the current air battery, the power and current output of the cell is limited. However, it is already sufficient of powering various milliwatt devices which generally require megawatt or microwatt level of power in the future. The performance of further improving the optimization PBC itself or employed efficiency over catalysts. Then figure B exhibits the galvanic discharge curve of the cell is 1 milliampere with only 3.5 milligram even while the present could discharge stability of 3 hours around 1.1 volts and calculated even specification capacity was high at 900 grams after the discharge. Was found the large portion of A1 foil was not consumed but separated from the anode current collector. Large portion of it It was found the large portion of A1 foil was not consumed but separate from the anode current collector as shown in the inset leading to a great waste of A1. This issue should be tackled in the future of further improve the discharge efficiency. After the discharge, the use of PBCE was taken out absorbed its surface morphology, which is slightly large portion than the fresh PBCE. Then figure D demonstrates the element mapping of the used PBCE. Apparently, the anode reaction product was left behind the use of PBCE, which contained only this for elements. As a CE exhibit the galvanic discharge curve of cell 1 milliampere centimeter square air battery. The flexible air battery and battery package with PBCE. Compared with grid batteries, flexible battery utilize the more complex and dynamic environment such as powering varying device on human body. Till now, different types of flexible power source have already been developed, including both primary batteries and secondary batteries. The present PBC is very promising for fabricating solid flexible even air batteries. As shown in figure A, compress the mechanical performance with a peak power of density 2.4 milliwatt. As shown in figure B, when bended for 60 degree and discharge 1 milliampere, the flexible cell could not also separated for 160 minutes, achieving high A1 specification capacity of 767 mega ampere. The result was demonstrated the good flexibility of this battery. Further, the utilized of PBC has also enabled the easy fabrication of high voltage, lightweight and flexible ion batteries pack. As shown in figure BC is 10 single cells were fabricated within a single piece of filter paper with a size of 3.5 centimeter and to 1.4 centimeters. The totally device weight was only 138 milligram. The 7 batteries are packed could generate the 0 volt high as 13.2 volts, which has main when other batteries are without PBC was provided the alkaline NaOH electrolytes. The ion connection among the single cell would generate characteristic shift currents inside the stack, leading to a 40 volt 1. Conclusion: the novel type of PVC has been developed the facilities to liquid-free operation of even air batteries for various milliwatts applications. Mechanical rechargeable battery with PVC can generate 1.5 watts and peak power density of 3.8 watts, which is sufficient for milliwatt devices. Even specific capacity is as high as 900.8 milliampere without internal discharge. The micro even air batteries pack can be generated in 132.2 watts for the fabrication of a high efficiency flexible batteries package with 10 shells connected in series. Thank you.